All right, welcome back. This is Art Lembo again, and we're continuing in our series on analyzing COVID-19 data with SQLite. If you're just jumping in right now, I would encourage you to go back and look at least the first two videos because they're going to give you a little bit of a background into what we're doing, how to get the data, how to load the software, and then just get started with all of this. If you're new to my channel, make sure to subscribe so you can get videos as I update them and continue with this series as well as other technical series that I use in the area of open source software, GIS, databases, and statistics. So as we move on, we're going to look at a little more intermediate SQL with the statewide COVID data that we've been looking at. And here we're going to bring in other tables. In fact, we're going to look at population values. So we're going to revisit one of the tables that we brought in from the very beginning that we really haven't talked about up until now. As we start bringing in more tables with SQL, it gets a little more abstract. I wouldn't say it's hard, but if you've never done it before, it can be a little bit confusing. But you're going to still see that the SQL is very English-like. So if you're technically savvy, you can start modifying the scripts that I'm going to show you to do even more creative things. So we're back here in SQLite or SpatialLite, the SpatialLite GUI that looks at SQLite. And remember, we brought in different data sets. One was the state, and I can say again, select star from state. Let's just see what's in that. And that's all kinds of statewide values along with geometry values. So we can actually make a map of the statewide data, and we can preview that map. You can see the states there. Another one that I brought in, and you can bring this in too. It's just I didn't want to have to go through the whole process of bringing all this data back in, so I just loaded it in here in the beginning. And that's state pop. Now the other ones we bring, the county or the COVID county and the data daily, we bring that in every day, or if we want to bring it in every day, because that way it's more current. But these statewide populations aren't going to change. And if we look, some very interesting things. This is just a table. There's no geography related to it. But we have the population estimates from 2019, and you can see it's for the whole United States, and then we have it for each of the states. The other really cool thing is the United States is divided into different regions for the Census Bureau as well as different divisions. Just a refresher for those who haven't seen it before. So these are the different census regions. There are 4 of them, and the census divisions. But we have a problem, and I chose not to fix it for you. We're going to fix it ourselves. Look at the state name: Alabama, Alaska, Arizona, Arkansas, California. Let's do daily. Right? That's where our COVID data comes from. For the state, let's limit 10. Why not? We'll just look at the first 10 states. Well, first 10 records. AK. There is no Alaska, Alabama, Arkansas anywhere in this data set, is there? Uh-oh. How do we link them together? Well, the way we do that is we have a third table called state. And that's the geometry tables we've looked at before. And here we have the name Maryland, and we have the Postal Service designation for Maryland, MD, IA for Iowa. So let's look at how this works. We're going to have to link 3 of these tables together. And in many ways, states is our Rosetta Stone. Because state says Maryland, it also says MD. There's no way for me to get the daily to talk to the state population. They don't have similar fields. However, we can link the state to the state population using that name field. They both use, say, Maryland. Then we can link the states to the daily using the UPS column as well as the state column in daily. So those both say MD. Then we'll transfer the population estimate data into daily. So let's look at this. We're going to select the state UPS and the state population data from the two where the names are equal to one another. So we run this. Now you can see we have the population estimates associated with the individual states. And if you look here, we have MD, Maryland, right? IA, Iowa. So that worked. That's a good thing. Now that's this query right here that we just did, right? Same thing, but now we're going to extend this a little bit. We'll copy that and we'll put this into this query. So what are we doing here? Well, remember this is a table, so I'm going to get the geometry. So we have the geometry from the state table, which you see here. There's our geometry column. And we have the population value from the state pop table. Again, where those names equal. So that's basically what we're looking for, but we've just added the geometry field in this case. And then this is another table, and this is another table. Here we're getting the sum of the positive increases as the total positive increases, and this is from daily. And we're going to group it by the state. So this is going to be another table called state COVID. So we're going to look at where that state for state COVID is, and that's really coming from daily. So that's going to give us our MD, our NY, and the state pop, the USPS, is going to give us that MD and NY as well. So where they're joined together, we're going to get the geometry, the state USPS designation, the population, and the sum of the positive increases. And there's our data. Now we could also select and I probably should have done this too. Why don't we do that real quickly, just to show you. Comma, and let's do death increase. And there it is. So now, oops, that was wrong. I need to call that as total death. And there it is. So that's our total death, our total positivity rate. So think about what we have now. I've got my population, and I've got my total positive and my total death. All right, that's up until now. Remember, we can always go back and use a where clause and then where the date, right? So we can start working with the dates. I'm just grabbing it here. You are free now to take some of those other queries where we looked at July or between April and July. You could do all of that. And now we're going to look at getting the percent positive. Copy that. We'll come back in here and we'll paste it. So let's talk about it. How do I get the total positive? Well, the way to do that is, or get the percent positive, well, the way to do that is to take the total positive, which we now have, and divide it by the population. Well, this query, right, is all stored in memory as I run this SQL. So this part of the query is returning this table that we see here. So I just need to do the division. Now remember, and again, sorry we have to do this, but we have to use the cast clause because the values are actually text. So we want to bring those in as real so we can do the division. And so this is calculating it for the percent positive. And there it is. That's our percent positive. Now we can also, let's copy this. This is something else that I do, and you can probably do the same kinds of things. All right, we'll come back. Instead of tote positive, tote death as percent death. Oops, sorry about that. We have to create the sum of death increase as tote death. There we go. And I need a comma. There we go. So now I have my percent death. Oh, I got to do one other thing. And let's get this in here. There we go. And tote death. Percent death. That's better. Okay, so now I have my percent death. So this is percent of the population that has died from COVID-19, the percent of the population that is has a positive case. Again, as of this date, we can also do this for different dates if we want, but I'm not going to bother doing that. I'll leave you to do that. Well, I kind of like where we're going here because I've added the percent death and the percent positive as well. And I can also add the total death as well. Tote death. There we go. So now I have the total death, the total positive. And you'll see we have a geometry field. We're not going to do anything with this right now. Later on, I'm going to show you how we bring in some software to then take this database table and visualize it as a map. But we're going to hold off on that for a moment because what I want to do next is move into another kind of an intermediary type of a thing we can do with the data. And for this, I want to analyze those regions and divisions. So let's just copy this and we'll throw that into our data. So here I have, I'm selecting, remember we have the region value. In fact, let's get back, well, let's just select this value here. So let's copy this and bring this in here, which I've done. So let's look at our data. I'm going to bring in all of this data, the population and the state name. And I'm also going to select, this is what we did before, right? So this is the previous query for the most part, where we are just getting the population and the state name as well as the sum of the increase in positive rates for each state or for each day and each state. So this query is going to give us the total positive increases for the entire country and group it by the state. We're going to join that to the geometry, right, and the state names and the state population data. So all these population estimates. That's another table. So now we're pretending that this is one table. The next thing we're going to do is we're going to get the region and we're going to sum up the positive cases and we're going to get the average of the positive cases and the standard deviation of the positive. And again, getting the total population and getting the standard deviation, total positive rather, and getting the standard deviation of that. Then we're going to group it by the region. So if we run this, now this tells me I've got these 4 major regions, and this tells me the average or the total number of positive cases in that region, the average positive cases, and the standard deviation and the coefficient of variation. And if we come back into our table, we can see, for instance, that region 4, the western region, looks like there's Arizona there. Here's Colorado, right? We'll find California in here as well. So region 4 is the west. Here's Connecticut. So that's the north, or that's the northeast. The south is region 3. Right? So then the Midwest is region 2, and you see Illinois in there. So we just need to understand that first because those are just given as coded names. So when we look at this, you can start to see again which regions have higher positivity, higher averages, and then what do we see in terms of variability in each of the regions. So we see that the Northeast has actually, no, actually the West has the largest coefficient of variation, probably because California has so many, and you're dealing with some smaller states within there as well. So so actually Texas would be in the South. So the South is number 3, so that's 1.11, and then the Midwest has the lowest coefficient of variation. So they have the most similarities in proportion to their mean in terms of their differences over the course of the pandemic. And now, of course, the next thing we can do is change that to division and run that. And now we have the 9 different divisions. And then you can go in and try to code those as well. So you can see from this video where we were able to take another table of population values and associate it with the the main table we've been looking at, and I threw a little bit of a curveball at you, right? We had data columns that didn't quite match up, so we needed a third column to sort of make that jump. That gets a little bit advanced in what we're doing, so sorry I kind of threw that at you right out of the gate in terms of learning how to join tables. But you can start to see the power, and also, again, that it's not all that difficult. These things appear to be very English-like. So that's it for this video. We're going to move on to the next video to look at some ways to do real statistical analysis. We're going to use a test called the analysis of variance. So we're going to look at that. Again, if you enjoyed this video and learned something, hit the like button. Please share down below how you're starting to make use of the COVID-19 data and SQLite and SQL to explore your own questions. And remember to subscribe to the channel so that way as more videos start to come out and we bring in some of the spatial aspects of things and start working with the county data, you'll be assured of